Okay, today we will do, I think maybe, I think we'll skip the review. I want to give you guys a challenge problem, and then we'll continue, and we'll start circle geometry. Okay? So, did anyone write the Kaylee contest? Nope. Okay. Um, okay, so I wrote the Kaylee contest a day or two ago. There was this problem I found pretty interesting, so I'm gonna share it with you guys. So, uh, yeah, okay, I don't think the answers are online, but whatever. Okay, so point A is at -3, 5. All right. Point B is at 0, 7. Point C is at R, T. Okay. Point A, B, and C are all in a line. So like if you join up point A and B, it forms a line, right? And if you join up point A to C, it also forms a line. They're all in one line. And then it's asking us for the sum of R plus T. Yo, I'm realizing this is kind of cooked. This is like a really maybe a bit too challenging. It's okay. You guys want to try it on your own, or do you want to have me explain it? It's a it's obviously like coordinate geometry, but also like I think it's just thing you have to like realize a trick to it, right? You guys want to try it? All right. You yeah. What's your first guess? What? You're trying to find R plus T. So point C is at coordinate RT, right? So then you're trying to find R plus T. I wonder if it's on my KV contest 2025. Past contest. Uh, 10. I don't think Kaylee's up yet. Oh, yeah, it was just Wednesday, yesterday. I don't think it's online yet. Maybe. Let me check my laptop. I might still have the PDF. Yeah. Okay, I still have it. Oh, yeah, okay. Here, I have the full thing. Let me type it out. Insert text box. I'll insert text box. Oop. Oh, I can just type. Oopsie. Okay. Points A and A, B, and C lie along a line if BC is equal to 4AB and R is greater than 0. What is the value of R plus T? I think I might have actually fumbled this question when I did it. I don't know, like, I know I got the right answer after I wrote the thing, but then, like, I don't know if I put in the right answer, which is kind of dumb, but, like, I think I might have put in the wrong answer. Okay, anyone have a solution? Okay. You're actually not that far off. UP, you got it right. It's 27. All right. Okay, I'll show you guys how to do it though. So we have point A here, right? We'll label this as point A. It's at -3, 5. We have point B round up here, we'll say. This is at 0, 7, right? So this forms a line. That's a very terrible line. And then this also forms a line to C here, which is at R, T. So then we know that all of this forms a straight line. There we go. That's a bit better. Okay. So we can draw some triangles to help us calculate this, all right? So this is 2, right? Because the vertical distance is 2. 7 minus 5 is 2. And then this length is from -3 to 0. So then that's 3, right? And then there's another triangle up here. And you can also extend it past down here. So then we have this and this, right? So then 3 squared plus 2 squared, which is then going to be 9 plus 4, gives us 13. So then therefore, AB is a length of root 13. Okay. So then now we know that this triangle here, BC, and then we'll label this as, say, I don't know, like theta or something. So then we know that this triangle here has the same ratio. Like it's a similar triangle as triangle like AB here, right? Because they're all in a straight line, and then this is always 90 degrees. So then that means that this angle and this angle both have to be the same. So then since we know that BC is 4 times AB, since from our original question, it gives us that. So then we know that this is 4 root 13, right? And then we also know that this and this have a ratio of 3 to 2. So then we'll label this as 3x, and we'll label this as 2x. So then now we can solve for x using Pythagorean again. So we know 4 root 13 squared is equal to 3x squared. Square should go out there. 3x squared plus 2x squared. So then that then means that 16 times 13 is the same as 9x squared plus 4x squared. So then 13x squared is equal to 16. So then times 13, so then 16 is equal to x squared, and x is equal to positive -2, but we obviously can't have like a negative distance for this. And it also says that r is greater than 0, so then we can't have it be negative. So since now we know that x is equal to 4, sorry, not 2, x is equal to 4, so then we know that this is then going to be 12, right? So we have this triangle here, and this as B at 0, 7. Then we have C at R, comma T. So then we know that this is 3 times 4, and then this is 2 times 4. So then 12 and 8, right? But then you also have to consider that since this is already 7 up, you have to add 8 to 7 to get the coordinate for t. So then the coordinates are then going to be 12, comma 15, and 12 plus 15 makes 27. Does that make sense? Okay, cool. You guys want to try more Cayley problems, or just start circle geometry? Okay, circle geometry. All right. Lesson 1, angles in the circles theorem, ACT. So definitions, a chord is a line segment with both endpoints on the circumference of a circle. So this is a chord, right? EF is a chord since it goes, both ends are on the circumference. Does that make sense? Yeah. Okay. An arc is part of the circumference of a circle. So this is an arc. 2 points divide the circumference into 2 arcs. So we have one arc here and another arc on the other side. I think, yeah, major and minor. Okay. The major is the larger arc, and the minor is the smaller arc. A central angle has its vertex at the center of the circle, and I think, sorry, 2 chords form the arms. Or you can say, like, yeah, 2 chords form the arms, but then they're also radii, right? Like this is the radius, and this is also the radius. So, okay, an inscribed angle has its vertex on the circumference of the circle. And 2 chords form the arms. Not radii. Okay, inscribed angles theorem. In a circle, all inscribed angles subtended by the same arc are congruent. Inscribed angles subtended by equal arcs are congruent. So if we look here, they all have this point A and point B and this arc, right? So then this angle is the same, this angle is the same, and this angle is the same. No matter where it is on the circle, it's always going to be the same. Does that make sense? So then the central angle and inscribed angle theorem. So in a circle, the measure of a central angle subtended by an arc is twice the measure of an inscribed angle subtended by the same arc. So for example, here we have AB, right? Again, the arc. And then we have this point, which is the center of the circle. And this angle formed by two chords or radii that go from point A and B to the center, this has twice the measure of this angle. And the same here. So P and Q make this arc, right? And then this central angle has twice the measure as this angle here, which is an inscribed angle. Does that make sense? Yes, no? Okay, cool. Angles in a semicircle theorem. All inscribed angles subtended by a semicircle are right angles. Well, it's fairly simple. Just half the circumference is an arc, then any angle is 90 degrees, right? So this is 90 degrees, and then if you draw it like this, that's 90 degrees. It's always going to be 90 degrees. Okay. Determine the measures of angle x and y. Justify how each measure was found. Okay, so we have y here and we have x here. So first of all, we can find some arcs. So we know that this point here, sorry, wrong line. So then this line here, DB, and DC. So then you can see here this arc, kind of that one, right? You can see that D and A are both subtended by the same arc, right? Here, like I don't know why this is so hard to explain. Like it's like you can just kind of understand it, right? So because they're subtended by the same arc, they have the same angle. So then angle BAC has the same measure as angle BDC, and BDC has 70 degrees. So then angle BDC is equal to 70 degrees, and then the reason is ACT, I think, or inscribed angles theory. Yeah, inscribed angles theorem. Okay. Now it's asking us to find the measure of x. So we can use this using not Pythagoras. What is it? Like all angles in a triangle add up to 180, right? So we know y is equal to 70, and then it gives us this measure here. So 105, and then the straight line would have an angle of 180, right? So 180 subtracted 105 gives you 75. So we know that this internal angle here, 75 degrees. So then 75 plus 70 gives us 145. So then x is then equal to 35 degrees, since all angles in a triangle add up to 180. All right. Okay, so here, again, we have this arc here that subtends both this angle here and this angle here. And since we know this is 25 degrees, that means x is also equal to 25 degrees by the inscribed angles theorem, IAT. And then you can solve for y, since we have here another arc that subtends this angle here and this angle here. So then since y and this angle are the same, y is also equal to 35 degrees, also by inscribed angles theorem. Any questions? Okay. Try this one on your own then. Determine the angles, the measures of angle 1, 2, and 3. Justify your answers. So we're looking for this angle, and this angle. All right. Try it on your own. Okay, anyone have their answers? Okay, that's fine. Uh, 2 is equal to 65 degrees. Is that good? All right, so I'll go through this one by one. So angle 1, right here. So we can see that this arc and this arc are the same size, right? Since they tell us that with the dash, so then this length and this length are the same. So then that means that they're both subtended by the same arc, and thus 1 must be the same as 30 degrees. Does that make sense? Yeah? Okay. So then angle 2, right here, you can see that it's subtended by this entire arc over here. This arc over here, right? So angle 2, and we know that O is the center of the circle. So then this angle here and 2. So then angle 2 is half of what this angle is. So then that's 30 plus 70 plus another 30. So then that's 130, right? 130 divided by 2 is then going to give us 65. So then angle 2 is equal to 65 degrees. So now we have angle 3 here, right? So angle 3 is subtended by this arc, right? And then we also have another arc of the same size over here, right? So then this arc has an angle of 40 degrees, right? So that means that angle 3 has to be the same since its arc is the same as this arc. So angle 3 is equal to 40 degrees. Does that make sense? Any questions? Or we can move on. No? Yeah? Okay. Cool. So determine the measures of angle A and angle B. Angle A here and angle B here. Okay. Whoa. Okay. So we'll start off with angle B because it's the first one I saw. So angle B has this arc over here, and then this arc over here is the same, right? Indicated by the two dashes. And then this arc has an inscribed angle of 40 degrees. So then that means that angle B has to be the same as that. So angle B is equal to 40 degrees. Whoops. Since the arcs are the same. All right. So then angle A has this arc as well here. Just draw out the lines, make it a bit easier to see. So angle A is like this, right? So then it also has the same arc, so then angle A is also 40 degrees. Does that make sense? Yeah. All right. PAT practice. The following questions have been taken from released PAT material. Point O is the center of the diagram below and represents the center of the circle. I read that so wrong, but it still made sense anyways. All right. Determine the value of angle X right here. Okay. So first of all, we need to solve for this angle over here, right? And then we know that X is going to be 1/2 of whatever this angle is. So then here we can see that we have a triangle that they give us and they draw a small line over here. So then that triangle, like this. So then because both of these points, both of these chords go from the center to the circumference, that means that both of these are radii and are therefore equal. So that means this is an isosceles triangle, and then that this is also 75 degrees. I wrote it a bit small, but 75 degrees. So then 75 plus 75 give us 150, right? So that means that this angle is then going to be 30 degrees because all angles in a triangle add up to 180. So you know this is 30 degrees. So then 30 degrees plus, I kind of blocked it out, let me see. 30 degrees plus 94 degrees is then going to be 124 degrees, right? So then this arc over here is 124 degrees. And x is going to be 1/2 of that. So then x is equal to 124 divided by 2, and x is then going to be 62 degrees. Any questions? Okay, cool. The letter O in the diagram represents the center of the circle. Note the diagram shown above has not been drawn to scale. If the sum of AOB and ACB is equal to 75 degrees, then angle ACB is equal to what? Okay, so here, angle AOB and ACB is equal to 75 degrees. Okay, so this angle plus this angle is equal to 75 degrees. All right, so they're both subtended by the same arc. And since this is the center of the circle, that means that this angle here is twice the length of, not twice the length, twice the measure of this angle here. So then angle AOB is equal to 2 times angle ACB, and then angle AOB plus ACB CB is equal to 75 degrees. So then that means that ACB is equal to 25 and AOB is equal to 50, right? So if AOB is equal to 2 ACB, then we can replace that here, right? ACB, 2 ACB, sorry, plus ACB is equal to 75 degrees. since we know that AOB is equal to 2ACB, so we're going to replace that here. So then 2ACB plus ACB is 75. So then 3ACB is equal to 75 degrees. And then ACB is therefore equal to 25 degrees. And AOB is equal to twice that, which is 50 degrees. Does that make sense? This is a fairly short unit, I think, but there's a lot of practice that we should do. No questions? Just grab the next lesson. Okay, so CPBT, chord perpendicular bisector theorem. Okay, a perpendicular bisector of any chord of any given circle must pass through the center of that circle. So any line that goes through the center of a circle and is perpendicular to a given chord bisects that chord. So chords that are equal in length are equidistant from the center of the circle. So for example here, these two are the same length, right? From here to here is the same length. So then that means this is 90 degrees, and this also passes through the center of the circle. So from the given information in the diagram, what can be stated as being true? Justify your answers. Okay. So we know DF is equal to EF. We know that this passes through the center of the circle. So then that means that angle OFE, or line segment OF, is perpendicular to line segment DE. So FO is perpendicular to DE. All right. And then we also see here that this is 90 degrees, right? So that means that this and this are the same length. So then AC is equal to AB. Does that make sense? That doesn't necessarily mean that AC and DF are the same though, right? Because you can draw like one that goes all the way out here and it's just a tiny little chord, right? And then these will be the same length and this is 90 degrees and it's obviously not the same length, right? So that doesn't necessarily mean that AC and AC and DF are the same length. Does that make sense? All right. So determine the value of x to the nearest tenth if the radius of the circle with the centimeter O is 9 centimeters and chord AB is 12 centimeters in length. Okay, cool. So radius is equal to 9 and then AB is 12 centimeters. So then that means this is 6 and this is 6. And it's asking us for the value of x. So we know the radius is 9 centimeters. So then if we draw from O to A, that's the radius, right? And we know that's 9. And then since we also know that since this bisects AV, then that means that this is 90 degrees. And now we have a right triangle that we can apply Pythagorean on. Oh, that's a terrible right triangle. Let me redraw that. There you go. That's better. So this is 9. And then one of the lengths is 6 and the other one is x. So then 9 squared subtract 6 squared is going to give us x squared, right? So then 81 subtract 36 is going to give us x squared. And that's what, 55? No. She's going 45? Really? That's terrible. Am I wrong? Oh, that is 45. The hell? Okay, so then x squared is equal to 45. X is equal to root 45. And it says to the nearest tenth, so then square root 45, 6.7 Yeah, 6.7, because to the nearest 10. X is equal to 6.7 centimeters. All right. Does that make sense? Any questions? No? Okay. Okay. Water is lying in the bottom of a horizontal circular pipe. If it is 20 centimeters deep in the middle of the pipe, okay, so the 20 centimeters is referring to the water, right? And if the width of the water's surface is 80 centimeters, calculate the diameter of the pipe. Include a drawing. Okay, cool. So it might be easier if I just draw it out. So we have a circle, right? We have some water lying at the bottom. And then we know that the water is 20 centimeters deep. And this width of the surface of the water is 80 centimeters. So that means that this and this are both 40 centimeters each. We'll draw from the center of the circle down to here. So then now we just have to use Pythagorean, right? Except how do we do that? There's some trick to this. I remember doing this a year or two ago. Hold on. 40 centimeters is 20, so you can solve for this length, but that doesn't really help you all that much, does it? There's a way to do this. So you have two right triangles, right? Yeah, this is 40, this is 20, and then 40 squared is 1600, and then 20 squared is 400, so then that gives you 2000, so then this is root 2000. That doesn't really help, does it? We also have like this triangle, right, with base 40. Oh, I'm spit. This is radius minus 20, right? And then this is radius. So then, okay, it's fine. Okay, 40 squared, right? Plus r minus 20 squared is equal to r squared. So then 1600 plus r squared minus 2, no, 40r? Yeah, 40r plus 400 is equal to r squared. So then r minus 20 squared is a binomial squared, and huh? What's up, college? Oh, we're trying to solve for, let me see. Where did it go? Oh, here. I'm trying to solve for the diameter of the pipe. Okay, cool. So this is binomial squared, right? So then that's a squared minus 2ab plus b squared. So then minus 2ab, so then that's minus 40r, so then 1600, and then the r squared cancels out on both sides. So then plus 400, and then is equal to 40r. So then r is then equal to 2000 divided by 40, which should be 50, right? R is equal to 50, and then diameter is equal to twice of that, which is 100. That should be right. And then I think it's like if you extend that, that should be right. 50 squared gives you 2500. 2500 subtract 1600 gives you 2000. 2000 divided by 40 is equal to 50. Yeah, okay. R is equal to 50. So then 50 squared, 2500, subtract 40 squared is 900. Yeah, okay, and then root 900 is 30. So then 30, 20, 50. Yeah, okay, that's correct. Does that make sense? Like, I feel like I've just kind of been rambling. Okay. Here, so this is the radius, right? Since it goes from the circumference to the center, so this is the radius, and this is the radius. We know this is 20, so this is then going to be the radius subtracted by 20. This is going to just be the radius, so then the radius squared, Pythagorean, right? Radius squared is equal to we'll call this a, right? A squared plus b squared is equal to the hypotenuse squared. So then 40 squared plus r minus 20 squared is equal to r squared. So then 1600 plus r squared minus 40r plus 400 is equal to r squared. The two r squareds cancels out. So then 1600 plus 400 is equal to 40r, since we'll just add 40r to both sides and move it to the other side. So then 2000 is then equal to 40r, and r is equal to 2000 divided by 40. So that's going to be 50, and the diameter is therefore equal to 100 centimeters. Does that make sense? Questions? No? Okay. A spherical, not a spherical fishbowl. A spherical fishbowl has diameter 26 centimeters. The surface of the water in the bowl is a circle with diameter 20 centimeters. What is the maximum depth of the water? Include a drawing. Okay, so we'll look at this from the side. Okay. So we have a circular. Oh, no, that's terrible. Okay. We have a circular fishbowl. The surface of the water has diameter 20, and the diameter of the fishbowl is 26. All right. So then that means that the radius is then going to be 13. And if we draw a line from here to here that bisects this, that means that each of these is 10 and 10. All right. And then this is, we're going to solve for this. This right here, we'll label that as x, and then we can just add that to a radius to find the depth of the water. Right? Because when it's in the center, it's the maximum depth of the water, right? So we can solve for x using Pythagoras once again. So we have this triangle here, which has the hypotenuse as the radius, so 13. We have one of the lengths as 10 here, and then we have x, all right? So then x squared plus 10 squared is then going to give us 13 squared. So that, excuse me, sorry. So then x squared plus 100 is equal to, I believe, 169, but I don't remember. 169, yeah. So then x squared is then equal to 69, and then x is then equal to the square root of that, which is square root of 69, which is 8.31. So that's 8.31. So then x is equal to 8.31, and then we add that onto the radius. So then 13 plus 8.31, which is then going to give us 21.31, and our maximum water depth is then going to be 21.31 centimeters. Does that make sense? Any questions? No questions? Okay. We have two more problems. I'll do this one, and I want you guys to try the last one. Okay. Pedestrian underpass is constructed beneath a roadway using a cylindrical pipe with radius 1.8 meters. Bottom of the pipe will be filled and paved. The headroom at the center of the pipe is 2.8 meters. What is the width of the path? Okay. So in total, this is 2.8 meters. So then we know that this length is then going to be 1 meter. Since this is the center, that means this is 90 degrees. We can draw a triangle here. And then we can solve for this, and then we know what this length is. You know, this is 0.8, right? This length here is 0.8. I don't even need that. We can just solve for it anyways. Yeah, disregard the 0.8 thing. So then we have a right triangle, right? So we have the hypotenuse, which is the radius of 1.8 meters. We have one of the bases, which is 1 meter, and we're trying to solve for the width of the path, or half of the width of the path. So then that's then going to be, we'll label that as x, all right? So 1.8 squared subtract 1 squared is then going to give us x squared. So then 1.8 power 2 is then going to be 3.24. So then 3.24 subtract 1 is equal to x squared. X is therefore equal to, x squared is equal to 2.24, and x is equal to the square root of that. Since square root 2.24 is 1.4, we'll just say 1.5. X is equal to 1.5. So then that means that the width of the path is 2x, which is then going to be 3 meters width. Does that make sense? Questions? Yes, no? Okay. You guys try this problem out. So the diagram below shows a circular pipe that has O at its center. The radius of the pipe is 20 centimeters, and it's asking us for the maximum depth of the water in centimeters. So there's some water at the bottom, right? It's asking us for the maximum depth of the water, right? Why don't you guys try this? Okay, does anyone have their answer? Yep. Okay, cool. Let's go over the answer. Or does anybody need more time? Okay. You have your answer? Yep. Okay. Let's go over the solution. Okay. So we know the radius is 20. So we can draw a line here. And then we know that this entire width is 32. So then since this is perpendicular, we know that's 16, right? Which is half of 32. So now we have a triangle with hypotenuse of 20. One of the arms is 16 and the other arm is x. So then the hypotenuse squared, subtract one of the arms squared gives us the other arm squared. So 20 squared subtract 16 squared is equal to x squared. So then 400 subtract 256 is equal to x squared. X squared is equal to 144, and then therefore x is equal to 12. So now it's asking us for the depth of the water here. So then we know that the radius is 20, so that this entire length is then going to be 20, right? We know that x is equal to 12, so then the radius subtract x is then going to give us this. So depth is equal to 20 subtract x, which is 20 subtract 12, and therefore 8 centimeters. Any questions? Okay, let's take a short 5-minute break, and we'll come back at 7:05. All right. Okay, let's continue. So I have another problem. Let's see, where did it go? All right, this is another Kaylee problem. This one's a bit easier. Okay, a jar contains 600 marbles, each of which is either red, yellow, or green. The ratio of the number of red marbles to the number of yellow marbles to the number of green marbles is 7 to 3 to 5. If 20 marbles of each color are removed, the new ratio of the number of red marbles to the number of yellow marbles to the number of green marbles is A, 5 to 1 to 3, B, 5 to 7 to 11, C, 13 to 5 to 9, D, 9 to 5 to 7, or E, 209 to 89 to 149. I'm going to do my solution while you guys do yours. Okay, anyone have a solution? Yes, no? Okay. No, I'll just explain it. Okay. So 600 marbles. We have red, yellow, green. So then the ratio between red to yellow to green is 7 to 3 to 5. You have a total of 15 marbles if you have that ratio, 7 plus 3 plus 5, right? So then you have a total of 600 marbles, right? The ratio says you have a total of 15, but in actuality you have 600, if that makes sense, right? So then that's 40 times the amount, right? 600 divided by 15 is 40. So you multiply each of the ratio amounts by 40 to give you the actual amount of each marble. So then 5 by 40 gives you 200. 3 by 40 gives you 120, and 7 by 40 gives you 280. So you have 280 to 120 to 200, which is red to yellow to green, right? So now we subtract 20 from each of these colors. So then we have 260 to 100 to 180. Now we just reduce this. We divide all of them by 10 to give us 26 to 10 to 18, and we can reduce all of those by 2. So now we have 13 to 5 to 9, and that means that our answer is then going to be C. Yeah. All right. Does anyone have any questions? No? Okay, let's continue with circle geometry. Lesson 3. Tangents. Okay, so tangents to circles theorem, TCT. So definitions. A circle is a set of points that is equidistant from a given point, a center. A secant is a line or line segment that intersects 2 points on a circle. So it's just like, right? A tangent is a line or line segment that meets the curve at that point. And the point of tangency is the point at which a tangent line touches the circle. Okay, so you have a tangent here, and it touches the circle at only one singular point. So if you have like a circle here, right? So I have like this tape, and then I have a ruler here, right? So then it only touches it at that one singular point, and this ruler is tangent to the tape. And the point where the ruler touches the tape is called the point of tangency. Does that make sense? Yeah? Okay. So tangent radius property. So a tangent to a circle is perpendicular to the radius at the point of tangency. So from the center to the point of tangency is perpendicular, right? Like this. So a line that touches the circle at exactly one point is tangent to the circle. A chord drawn perpendicular to a tangent line at the point of tangency contains the center of the circle and its diameter. Like this, right? Okay. So tangents from the same point are equal. So two tangents of a circle meeting at an external common point are congruent. So they both meet at this point here, right? And then they're both tangent to the circle, so that means that they're both the same length, and that this internal length is obviously going to be the same. So justify that angle AOC is congruent to angle OBC. So this 3 lines means congruent. All right. So we have AOC and OBC. OBCD, sorry. So you have this angle here and this angle here. So we can prove this in two different ways. Number one, since these are tangents, then that means that these are automatically 90 degrees. Since it goes from the radius to the tangent point of tangency, so that means that these are automatically 90 degrees, and we know that angle OAC is equal to angle OBC. You can also do this another way. Since they meet at a common point, that means that this length here and this length here are the same. We know that the radius is the same here and here. They're both the radius, and then this length is obviously the same for both triangles since it's only one line. So then since all three sides are the same, that means that the angles are also all the same. So then this angle here and this angle here are the same. This is the same, and therefore these two angles must also be the same. Does that make sense? Yeah. Okay. Let's continue. In triangle TSR, TS is equal to TR and its perimeter is 44 centimeters. A, B, and C are points of tangency to the circle. If SC is equal to 6, find the length of TR. Justify your answer by stating reasons for each step. Okay, so SC is equal to 6, right? So then SC and SB are going to be the same. Since they're both tangent to the circle, since it gives us that A, B, and C are points of tangency to the circle, so then this and this are both tangent, and then therefore these two lengths are the same, since they meet at the same point. So this is also equal to 6. So since it's an isosceles triangle, since TS and TR are the same, that means that since B is halfway, is like the halfway point of SR, then that means that this is also going to be 6. So then now it's asking us to find TR. We know the perimeter is equal to 44. We know this length is equal to 12. And then these two are the same, which we'll label as x, plus 2x, since there's two of them. So 44 minus 12 is equal to 2x. So then that's then going to be 32, right? 32 is equal to 2x, and x is then equal to 32 over 2, which is 16. Does that make sense? Hmm? Yes, no? No? Well, if nobody's going to answer, I'm going to just take that as yes. Okay. A cylindrical pipe touches a wall and the ceiling of a room. The pipe is supported by a brace. The ends of the brace are 85 centimeters from the wall and ceiling. What is the diameter of the pipe? And give the answer to the nearest centimeter. Okay. So this is 85 centimeters, this is 85 centimeters, and then that means that this point is tangent here, this point is tangent here, and this point is tangent here. What was asking? Diameter of the pipe. Okay. Point of tangency is 90 degrees. 90 degrees. 90 degrees. So these two are the same. This is 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 the same. Two ticks there to indicate that's a different length. So this is a square, no? You can kind of tell that I don't know really what I'm doing, but this is a square. Since this is 90 degrees, this is 90 degrees, this is 90 degrees, so this has to be 90 degrees as well. So we have a square here, and then we have 85. So then x is equal to r, right? The radius. So then 85 subtract x. Now look here, I don't know what I'm doing. Tangent radius property. It's perpendicular, yeah, and then that's diameter. So if it's tangent here, then that point is... It's not the diameter though. This is kind of sad. And I kind of forgot how to do this. Oh, I'm stupid. You can just solve for this length with Pythagoras. Whoopsie. 85 squared times 2 gives us, yeah, gives us this length, this total length here, right? So we'll label this as C. So the C squared, so then 85 to the power of 2 is 7225 times 2 gives us 14450. 14450 is equal to C squared. C is therefore equal to the square root of that. Square root of that is then going to be 120.208. 120.208. So then that means that this is therefore equal to half of that, right? This length here, we'll label this as, we'll label that as B. Why not? So then B is therefore equal to 85 subtract 120.208 divided by 2. So the reason we do that is because we have this entire length here. This bisects this right here. So then that means that this is half of the total length, and then that's half of 120.208. We know that this total length is 85, so we can solve for this using 85, the total length, subtract this length here. Does that make sense? So then B is then going to be divided by 2. 85 subtract that answer. That gives us 24.9. Okay, B is therefore equal to 24.9. Sorry, not B. B is, yeah. No, this isn't B. I'm sorry. The radius. The radius is equal to that. So then this radius here is equal to 24.9. This is 24.9. So it's asking us for the diameter of the pipe. So then that's just twice of that. So then that's 50 to the nearest centimeter, right? So 50. Does that make sense? Or like, I find the biggest thing is kind of like extending past like what the problem gives you. Because like if you just kind of like, I sometimes just like I don't like extend past the problem and I can't solve it. You just kind of have to like um kind of like think around the problem, if that makes sense. Anyways, okay, last problem for today. Provincial achievement test practice. The following are taken blah, blah, blah. Okay, the gong shown below is 30 centimeters in diameter. 30. The total length of the chain is 18 centimeters. So this is 9, and this is 9. Because the total length is 18, so each of those is half. The lengths of chain on each side of the nail are equal to each other and form a tangent to the gong. How far above from the top of the gong is the nail to the nearest tenth of a centimeter? So it's asking us for this length, right? So we can draw the center of the circle. We can draw this there. We have 90-degree. Oops. have a 90-degree triangle. Right triangle, like this. So then the hypotenuse is this length here. We'll label that as x. We have one of the arms is 9, and then the other ones is half the diameter, which is 15. So now we can solve for x. 15 squared plus 9 squared gives us x. So then 225 plus 81 is equal to x squared. So then 225 plus 81, and then square root of that. Okay, we'll just, yeah. Okay. So x squared is equal to 306. X is equal to the square root of that. So the square root 306, 17.45 or 49? 49. X is equal to 17.49. Okay. So now we have this total distance, and we need to solve for this length, right? So we can just subtract the radius from this. So then 17.49 subtract radius, which is 15, gives us 2.49. So the distance is 2.49 centimeters, nearest tenth of a centimeter, so 2.5 centimeters. All right. Does that make sense? Anyone have any questions? No? Okay then. That'll be class for today then. I will see you all next week on the 6th of April. All right. Have a good weekend. Bye-bye.